Hello and welcome to the microlecture on clustering. Before we start into the topic, here's a short recap from the microlecture Introduction to Machine Learning. What we learned in that microlecture is that clustering is part of unsupervised learning, so we work with historical data, but these are not labeled. Another recap from the microlecture data preparation. And its main takeaway is that we have different data types and that it's important to look out for these different data types. So we have numerical data, categorical data, Boolean data, text data, and date-time data. There are also more data types, but these are the most common ones. After listening to this microlecture, I hope you are able to define the term clustering and to identify clustering use cases, meaning that in real-world scenarios, you can say when to use clustering and when it's useful. Then we will also learn something about the distance measures: Euclidean distance, Manhattan distance, Hamming distance, and Jacquard distance. I hope that you understand how they are calculated and when to apply them, and that you can use these to analyze the similarity of data points. And finally, we will learn something about the k-means clustering algorithm, which is basically the most popular clustering algorithm, and the elbow method. To achieve our learning goals, you will be provided an introduction to clustering. Then we will talk about the difference between hard and soft clustering. Then you will get some information about clustering applications, so what clustering is used for in real-world problems, including customer analysis, medical diagnostics, image processing, and text analysis. And finally, we will talk about distance measures, which are used in different clustering algorithms. So what is clustering? It literally means grouping, so it's the process of assigning data points to different clusters or groups. And as you learned from the recap or from the original microlecture, it's an unsupervised learning process. And here we brought a short definition that says clustering analysis aims to group individuals into a number of classes or clusters using some measure such that the individuals within classes or clusters are similar in some characteristics and the individuals in different classes or clusters are quite distinct in some features. And it's commonly used in customer analysis, image segmentation, or also in behavior pattern analysis. In clustering, we differentiate between hard and soft clustering. In hard clustering, which is for example the k-means algorithm, each data point can only belong to one cluster. This means there are clear boundaries between these clusters, and the algorithms for hard clustering are usually applied when the groups are well separated. In soft clustering, a data point can belong to multiple clusters, and usually the algorithm provides probabilities to which one data point belongs to which cluster. And so soft clustering allows overlapping and fuzzy assignments, and it's very useful when data distributions are complex. Clustering has various real-world applications. Here's the list of some examples, and some of these we will, in the next slides, talk a little bit more about in detail. So the examples are customer segmentation, image processing and computer vision, text and document analysis, behavior, pattern detection, medical diagnosis, anomaly detection, and recommender systems. So customer analysis is one specific use case for clustering, and basically probably nowadays all the online platforms try to collect many data about their customers, especially like when you buy something, you have to provide them with your name, address, but they also collect data on what pictures you click on, etc. And these data are used to provide you personalized offers. So with the clustering algorithms, different customers are clustered into customer groups. So you have, for example, bargain seekers, which look for a discount or are very sensitive to price changes, or you have brand loyalists or occasional shoppers. And based on your assignment to one group, you get, for example,
more frequently or less frequently, emails from the newsletter, or you get, for example, pop-up notifications with, here, you might be interested in this product, right now it's on sale, that would be a special offer for a bargain seeker. So yeah, probably you all encountered this customer analysis effects once while online shopping. Another use case is the application of clustering in medical diagnostics. So here, patients are clustered according to their symptoms, gene expressions, or imaging data. So for example, data from an MRI or a CT scan. And clustering is done to support diagnosis and to personalize treatment. And for example, with the gene expressions, or genes are clustered in order to identify cancer subtypes from gene profiles. And the algorithms you can use for this kind of applications are hierarchical clustering, k-means, or Gaussian mixture models. And the data are usually high-dimensional genetic or image data. You can use the image processing or the clustering in image processing not only for medical diagnosis, but like in general, to segment pixels into region, for example, object versus background, or to identify a barcode or QR code on a photo. And applications are, for example, face recognition, also object tracking. There are certain applications with which you can track one packet through a whole logistics center. Yeah, and so one example would be to extract foreground and object from an image. And the algorithms you can use for these kind of applications are the k-means algorithm for color space, or dbScan. And the data usually are RGB values and spatial features. The last example we will talk about in detail is clustering in text analysis. So here it's used to group similar documents, for example, news information, tweets, or reviews. And it's, especially in times before ChatGPT, it was very useful to detect certain groups of topics. So for example, you have lots of reviews on a product, or I don't know, Google reviews, and you want to look for the especially bad ones or the ones talking about a certain feature. And then you can use clustering to identify these subgroups. And algorithms you can use is k-means, agglomerative clustering, and the data are TF-IDF vectors or word embeddings. So the starting point for any cluster analysis is the usage of distance measures. So you have different measures to define if two data points are similar or dissimilar. And then, as we heard in the definition on the slide before, you can determine if data points within a cluster are similar as you want them to be. And what is also important is that the distance measure depend on the data type. That is why we had the recap on data types, and you need to see if you have numerical data or any kind of other data, and then use the distance measure accordingly. For the numerical values, there are two very popular distance measures. One is the Euclidean distance, which is basically the root of the squared distance between 2 points. And the other one is the Manhattan distance, which is the absolute value of the distance between 2 points. And it's advisable to use the Euclidean distance measure if you have continuous data who are normally distributed, and the Manhattan distance for high-dimensional data. For non-numerical data, you could use the Hamming distance, which measures the points where, for example, two strings are not equal. So the more similar they are, obviously the lower the distance is between those. If you want to compare two sets with each other, you can use the Jacquard distance. And then you have to consider the intersection and the union of these two sets.
So the formula is 1 minus the absolute value of the intersection divided by the absolute value of the union. This may seem a bit abstract, so I've brought a little example. If we have two lists, like two shopping lists, what you want to buy, and person 1 wants to buy apples, pasta, and milk, and person 2 wants to buy apples, milk, and ham. So basically the only difference is that person A wants pasta and person B wants ham instead of pasta. And then you calculate the intersection. The intersection is 2 because both want apples and milk. And the union would be 4, so apples, pasta, milk, and ham. And then you calculate 1 minus 2 divided by 4, and then you get the distance of 0.5. I hope that by now you understood what clustering is and that you would be able to identify clustering use cases. Moreover, you learned what distance measures you can apply to your data. So there's the Euclidean distance and the Manhattan distance for numerical values, and the Hamming and the Jacquard distance for non-numerical values. And then we talked about the k-means clustering algorithm and the elbow method, which you should be able to apply now. Thank you very much for listening.